We're going to try to stick to a schedule here. So let me introduce our moderator for the next panel, Dr. Karl Thibault. Oh, no, I messed it up. All right, never mind. But yep, Karl over here, the co-founder at Q4 Climate Operations and Talent Development at IQ, Institut Quantique. I'm working on the French. Sorry.
All right, thank you very much. This is open. So welcome to the Readout panel for the workshop on quantum and sustainability that we had yesterday. Today, we've got three great panelists with us to do a quick summary of what was said during our workshop of approximately 40 people yesterday. So this 30-minute panel's objective is, as I said, to give you a quick summary. And today with me, I have Catherine Lefebvre, Senior Advisor at the Open Quantum Institute, Diederick Croese, Director at the Center for Quantum and Society at Quantum Delta, and Tess Dennis, Quantum Solutions Manager for Climate Technologies at PsiQuantum and Climate. With that, I would just give you a few minutes to introduce yourselves and your various initiatives to the people in the room.
Thank you, Karl, and thank you everyone who made it to the 7th floor to listen about quantum and sustainability, and hopefully you can participate in the future. So I work at the Open Quantum Institute, which is a global governance initiative that promotes global, inclusive, and equitable access to quantum computing, and through that develop applications that are good tackling global challenges and will benefit humanity. So we use the United Nations framework of the Sustainable Development Goals and also the subsequent framework that will follow the SDGs. So we have different activities in terms of developing use cases, tackling different SDGs, providing access to different QPUs, and also building capacities and targeting underserved geographies to participate, and also providing tools for diplomats. And it's really at the heart of the Open Quantum Institute is really a science diplomacy instrument in action. So we work with more than 25 countries to talk about governance of quantum computing for the SDGs and multilateral governance. So thank you.
Pretty cool. And so my name is Diederick Croese. I'm part of the Center for Quantum and Society of Quantum Delta in the Netherlands. Basically, we want to maximize the positive aspects of quantum applications and minimize or avoid the negative aspects of it. And you could say that on the one hand, we always talk about technological readiness, but this would be societal readiness. And we would prefer the society to be ready before the technology is ready. And on the other hand, we want to make sure that the quantum applications are towards a desirable direction, for instance, the SDGs. And that ethics is part of the design. So it's a principle instead of an after fact, a band-aid. And we have 3 research lines, so all kinds of scientists that work in values and ethics, so they're more of the philosophy department. Teams that work on law and governance, so how do you translate these values into supranational and national legal regulation, for instance. And the third one is science communication, so how do you involve the public in a way that gives them a vote also in this transition towards quantum. And we have all kinds of actions relating to end-user engagement, Quantum Beyond Borders, for instance. We are a partner of OQI, doing events at the UN. We have awareness, education outside of educational institutes. So there's also a line that does education within educational institutes, where we also do it for organizations, for instance. And the fourth one is that we create tools. And that tool can be range from a quantum board game to quantum escape room towards more technical tools that we build to have organizations apply these quantum technologies. Stop the time.
Hi. Hello.
Check.
Thank you. My name is Tess Dennis, and I work as a quantum solutions manager at PsiQuantum, which is a startup based in Palo Alto that's working to build and operate the first commercially useful fault-tolerant quantum computers. So my work is primarily in identifying commercially valuable and technically viable use cases for the fault-tolerant hardware that we're building, primarily in the quantum chemistry simulation space, although we also work on use cases related to solving partial differential equations. And a lot of my work has to do with our climate initiative, given that I cover work in the energy generation and storage domains, as well as chemicals production and agriculture. So climate is an initiative that was launched, it's spelled with a Q, and it was launched in 2022 in an effort to maximize the sustainability impact, particularly in the climate crisis, that our early systems will have. So through climate, we do work with customers to develop algorithms and corresponding quantum resource estimates for their problem statements of interest. We do applied research on what we see as the leading use cases. So for example, looking at biocatalytic ammonia production versus plasma-assisted versus electrochemical ammonia production, all different clean pathways. And then we also work more with domain scientists, so on the chemistry and PDE side, to build methodologies that will link the computational outputs of our quantum systems to real-world workflows and real-world impact. And next year, we'll be formally launching our Climate Research Center, which will sit in Australia. So while Diederick works more on the societal readiness side, we maybe work a bit more on the technological readiness side, but hopefully society will, both will come at the same time.
Perfect. Thank you all for this great introduction to your own initiatives. So our workshop's goal yesterday, first goal I would say, was to find out which quantum applications were the most impactful related to climate and sustainability and which ones we should prioritize. And we believe that it's still early enough in the quantum development to be able to do that. So that's why we tried to do it yesterday. And I'd like to start by quickly asking you what's the main application you'd like to share with all of us in the room today that you see would be the most impactful or we should prioritize in quantum for sustainability. Whoever wants to start.
Sure. Well, there was a debate, and there are 17 sustainable development goals, and basically everyone was agreeing that we should tackle all of them, and there's a way to accelerate through quantum technology all of them. But energy really came up as one of the priority, and education. And understanding that maybe we're so early stage that we need not only a grand challenge, but we need people to achieve them. And so bringing education, building capacity so that we can build these solutions and look at explore new ways. You leveraging quantum technology is what I noted. So energy and climate were pretty high, but education is really at the forefront. I have a background in quantum chemistry, so I get really excited when I hear hard problems in chemistry that can be applied to some SDGs around health, around energy, around food. But so that's a personal vision here.
Yeah, what I liked a lot is that to go over all the SDGs was fun because some of the SDGs, for instance, life in water and life on land, it was pretty hard to come up with quantum technologies. So there was somehow, we were all working on energy, and it made sense because we all want to have, if you solve energy, there's so much impact you can make across the SDGs. So it made sense, but it was cool to think through why we all chose energy, and then that's methane in Dutch. That's immediately something that was valuable in the sense that you see that so many, across the globe, so many teams are working on similar problems, that international cooperation just makes sense. It's just a global problem, and we know that. But it's cool to be in the same room and to see that we all choose specific SDGs to work on. And of course, we shouldn't forget about the others, There was an exercise yesterday that you had to award dollars to solving specific SDGs. And it was pretty cool to see that we were on the same page to a large extent.
Sure, yeah. I think a lot of the value from that exercise did come from the exercise of awarding dollar figures to these different 17 SDGs. And some of them that came to light, I think, were ones that I hadn't thought enough about, right? So thinking about, like, where does our hypothetical, $15, does that go further being piled onto our energy bundle, or does it go further being put into education, or even things that maybe we haven't explored as much, of looking at, how we can build a more sustainable ecosystem in terms of gender and in terms of gender equity. So I think that was a really enlightening experience. And of course, climate and energy were definitely two areas that came to the top in terms of new materials, new molecules that can be developed. But there's a lot else for the community to consider across those other 15 goals.
Right. Thanks. I was personally very surprised to see that education was so high up the list of every table. So that was also interesting to see. Moving on, the second, I would say, goal that we had yesterday was to figure out if we needed international collaboration to work on these different problems. And achieving the UN SDGs in itself is very ambitious, and leveraging quantum technologies to do that is also very ambitious. How much international collaboration do you think we need after the discussion we had yesterday to actually fulfill this promise, to use quantum for SDGs?
Sure. I think the answer is a lot, right? I think across all of those SDGs that we examined, the answer was that the intellectual capital that we as an ecosystem have is distributed across geographies. So when we think about the folks that have big pools of quantum algorithm developers or big pools of quantum software developers versus the leading academic institutes looking at food scarcity, food insecurity, or looking at new membranes, new systems for desalination and for water membrane, like for water filtration membranes. These all take place in very disparate groups. And we absolutely require international collaboration to bring these diverse sets of expertise together to bridge the gap from what's today, growing hardware effort, growing software effort, growing, luckily, algorithm effort, and real world impact. Because frankly, we don't have the time to do this in silos, and we don't have budget in terms of carbon budget to do this in silos. All of these efforts need to grow together, and they need to be orchestrated by international collaboration.
Boom. No, but I agree. And also budget-wise, financially. So I mean, I see everybody working with limited budgets on the same problems. So which makes sense, but we're not sharing. So it doesn't converge or it doesn't stack up as quickly as it could do. So we could accelerate by working together, and somehow that's hard but that you will touch upon a bit later. So I won't destroy that. But there were also limitations that came that we immediately found out that we needed to solve.
Yeah, maybe worth mentioning, there are other, I mentioned about the OQI, the Open Quantum Institute, that is global and really wants to create this international multilateral collaboration. Your activities are also global. There is the Quantum for Climate, that is the global, there is the Quantum Energy Initiative, there is global X Prize competition on quantum application that wants to encourage bottom-up approach to bring quantum for sustainability. And so there are these initiatives here and there that we really benefit to connect, glue together, really to scale, so that we have more collaboration, international, and more impact. One thing that thinking about international cooperation, interdisciplinary also activities, we also discussed the inequalities that can come, especially from using technologies that requires the access to the hardware. So we can think, okay, developing application on quantum computers, you can have access through the cloud and then run your algorithm. And there's so much to grow so that the community of practice can grow and we really all together have more impact. But there are like quantum sensors. You need access to the sensing hardware to use it and develop an application and use it for sustainability challenge. So we discussed that also, that the challenge of being global and who can have access to the technology, not just to develop it but to use it. And then there's a discrepancy between quantum sensing and quantum computing application.
Great. Thank you. Diederick, you alluded to that, to the next question. Which is, so if we want to scale and expand existing initiatives that Catherine mentioned to achieve real impact for the SDGs, what is it that we need in terms of funding mechanisms or global governance structures that don't exist today that could propel us to actually achieve these goals?
Yeah, so we discussed how to avoid the prisoner's dilemma. So how to have the benefit of working together and that we all win, basically, if you put it simply. And of course, there are things like return on investment or winner takes all kind of mechanisms that also play out in this quantum arms race, if you would call it like that. And so how to avoid that? One of the approaches would be thinking of new IP structures where there will be regulation to make it mandatory to give certain rights to certain regions, for instance, because we can't expect everybody to pay the same amount into the development. We talked about transparency, for instance, that it required you to be open so that you would immediately notice when somebody wouldn't be open anymore, that they wouldn't be open anymore. But we didn't solve it. What I like is that we went to thinking of supranational institutes and to what extent you can create larger bodies, like were also started after the Second World War, that have been very successful for a certain period, I must say now. And so how to install that. And then the idea came up to join, for instance, COP29. And I didn't think of that. So I was surprised by that. So the brainstorm turned out to be great, because we now might come together at COP29 to see how quantum can help out with climate in a network that is different and has some regulatory power.
Yeah, actually, there was a small quantum community that was at COP28 last year. So, but then I mean, it's a mini pavilion. So how to grow this and really have more impact? I think like from a large governance structure that you mentioned, like post-war, like ISS, for instance, the International Space Station. How can we reproduce that? What came up also from the discussion yesterday is, let's start small. Let's start like focus on 1 or 3 really key application, push them, have something concrete to show, and then scale from there. So there is I think the community kind of agreed that we should be focused and then impactful and then grow from there. What else? Yeah.
Yeah, I think that was a definite theme that we noticed as well at my table, which was that, right now there's so many disparate efforts and they're a little bit, the budget is spread thin, and also a lot of the time, sometimes work gets repeated between different research groups. So if there is an international body or an international agency that is tasked with identifying what are the things that are useful, like starting with those just 2-3 killer, maybe 1-2-3 killer applications, and really allocating the resources that are required for real world impact to those 2 or 3 efforts. And then if those are successful, moving on to the next ones. But right now, because there's so many different types of quantum hardware in different stages of maturity, and also so many different categories of applications that people talk about, I'm sure from the policymaker's point of view, it can be a little bit overwhelming when it comes to like, what are these things actually going to be used for? What real world impact are they going to attain? So I think starting small is a definite a theme that came to light.
Great, thank you all. I have a couple other questions I can ask you, but I would like to open it up to the room to see if anybody has a question that they would like to ask our panelists. So Go ahead. If not, then I can continue, but still. Anybody? Oh, yeah, one there. Thank you for your courage.
So for the inequality and access to hardware. So this is was that talked about like collaborating with other organizations for accessing or placing hardware, maybe so that they can have it in local environments for those like on the hardware side as well as those on like I know there's like so many. I'm part of the Q World Discord, and I know that there's a lot of people in like all these different areas of the world that are like software developers, but they just don't have any access to the hardware, and they might have like much more ideas than any of us in this room, but they can only implement it if they have access to hardware. So, is that something that's going to happen?
Yeah, definitely. What I appreciate, I've been only in the quantum context for a year now. But what I noticed is that there's a lot of talk about, for instance, Global South. So we've definitely learned from other emerging technologies and how that can create a divide. And so I think at least we're very conscious of the fact that it can create that divide. And we're trying to look into how we can create not only access, but even agency through education and beyond, to involve everybody. That doesn't say it's simple. So we, for instance, first you need to start mapping out what the problem is. So we recently published a white paper on the Global South and to do an analysis of what's happening across regions. And you see that there are also different strategies. That, for instance, Brazil was more into quantum networks, and or at least in the discussion, not so much only in quantum networks. But so basically mapping it out is important, and then try to see how you can involve everybody. That's, I think, the most important thing. But I don't have a clear solution.
Yeah, so if I can complement there are some initiative of open source development to access hardware, and because it's open source, then you can reproduce somewhere else. And there's some, like even in Canada, on the open quantum design, and there are more and more of these open source initiative to provide access and really put your hands on and access the hardware. And I mean, your question is really, it validates the mission of the Open Quantum Institute in trying to avoid the digital divide that could be amplified by quantum, and making sure that all geographies are included in benefiting from the technology and participating and developing solution. We have open calls to develop use cases, and then we support the team to further advance these use cases, provide free access to our industry partners to implement the use cases on the QPUs and on the quantum computers. So this is really in the mission of OQI. There is so much that we can do more, how we scale and how we scale with everyone. We're a small team with a large community, and it exists only with this growing and global community. So happy to further discuss too. And Q World is part of the OQI community.
All right, thank you. So we only have a few minutes left, so I'd like to just go for my last question. Yesterday we got about 40 people in a room, and I think it's really important for us to continue this discussion in the next few weeks, months, and years. So I'd like to give you all a few minutes to describe what you believe should be our next steps as a community to make sure that we keep the momentum going and realize the potential that we have here with Quantum for the SDGs. So maybe I can direct you also, since Tess comes from an industry background, maybe more an industry perspective, Diederick a societal perspective, and then Catherine last with a science diplomacy perspective.
Yeah, I think from the industry perspective, one thing that's really important is that we continue to focus on sustainability relevant applications. So I've noticed over the past year, especially through the DARPA QBI program, there's been sort of a flurry of papers that talk about quantum algorithms and corresponding resource estimates for various sustainability relevant use cases, right? So looking at like photocatalysis or other types of metal organic frameworks for carbon capture, things like that. And I think that we're lucky that as a community, we have our roots in academia. People are used to sharing with each other, and they're used to an open exchange of ideas and of even like looking at like different algorithm instantiation and compilation techniques. So keeping that conversation open between our companies. Granted, of course, there are IP concerns around any private sector player, but the applications stand on their own, and the applications are not owned by any one company. It's better for everyone if everyone is working on them, and also not just working on the quantum piece, but working with the computational chemistry community that have been wrestling with the same problems that now we are for many decades, right? Not seeing those people as competition or adversaries, but seeing those people as partners. We're going to need them and alongside the people working just on quantum for real world impact. So building more of an ecosystem around quantum computing for sustainability, for new materials, for new molecules, things that can be scaled, I think is something that I see a lot of value in over the next couple years.
So I think speaking the same language also helps. So we need to merge the worlds, and we do a lot of work in learning from other sectors as well. So for instance, when we talk to water companies, there's an education from the water experts towards the quantum experts, and the other way around. The quantum experts talk to the water experts, and you could do so for every vertical. Because it is the devil's in the detail. So to make sure that quantum applications actually work, you need to understand that from the bottom up and up down, from all angles, you need to understand the problem. So what we often do is that we have holistic sessions, group model building, you could say, where a diversity of people from all layers of the chain are in the same room to discuss this in detail. And then the magic happens, because it takes a while for all of them to speak the same language. So awareness and education, not so much physics, but in layman terms, trying to figure out how we should, what the added value is, and how to explore that value and how to realize that value is the most important challenge for now.
I think where also we can bring with the OQI and beyond is not only from the quantum experts to the water experts, but we also bring to the UN experts, the SDG experts, to the diplomacy experts, so that we can really have this global community that speak the same languages, share the same mission. So all the part on multilateral governance and bringing different nations to share that same goal and making sure that we're co-developing together solution, and hearing from different part of the world what are the challenges, and have them to bring up their challenges so that together we can find a solution where quantum technology can participate. So that's really what we want to do, what we're doing at OQI. That's really what we can do beyond OQI as a global community, I think, with the quantum for climate and beyond.
One more thing I would want to add, is that we need to update the narrative. So instead of walking in circles, telling the same story over and over again, which might happen in this community, because it takes a while, because the technology is in early stage, we need to have better narratives that keep being updated with new use cases and stuff, because otherwise the society gets bored and they move on. And it will be like nuclear fusion. And so we need to have a continuous updated narrative that we can work on together to make sure that we keep the attention span running.
Great insights. Thank you all. If any of you are interested in keeping the conversation open, please reach out to any of us. We'll include you in our future events. Thanks to all workshop participants that were there yesterday. Thank you to our great 3 panelists with us today. And thank you for being here with us on the 7th floor here in this building. Thank you.
Thank you, Karl.